Hey Scott, I wanted to update you on my progress in Unity, what I've been learning on there and the little game that I've built over the last couple of months. Of course, you know I'd still love to be your Unity developer if that's a possibility, so I wanted to show you what I've got so far, and not knowing when you'd come back through New Albany again, I figured I'd make this low-tech video to send to you. And so this is a camcorder looking at a big screen TV and just picking up my voice. No fancy screen capture or anything, but I figured this was kind of easier and quick. So anyway, so I wanted to make a game, and I had been thinking about making a little board game for myself that it was like a hex pattern, and I wanted there to be like some terrain, some hills and trees and whatever on there. So I thought, why not use Unity to try to generate that terrain for me on its own, randomly somehow, right? So what I've built in this game that I've built, I've actually put levels in to this version of the game to where it'll actually walk me through this demo with you. So let me get it started here. So level 1, very simple, just a plane of hexagonally positioned tiles. This is ground level, this kind of tan color, and you'll notice that I have at the bottom is the red man, that's my player, and the goal of this, since this is Discover card, is the goal of this game is to pick up all the orange globes, like from our logo, right? So I thought it would be interesting to try a different. I said, well, I thought I'd experiment with as I was doing this, with different kind of ideas. So one of my ideas for this game is this little player can only move forward, but you'll notice he's facing forward. I can actually rotate him around with my arrow keys. He's got a little white nose there. So now he's facing away from us, and he's facing he's facing in between those two tiles ahead of him. So what he can do is he can choose which tile he wants to go to, either move forward to the right and forward to the left. And he does that with using E, will move him forward to the left, and W moves him forward to the right. Then he can rotate around and still forward to the left, forward to the right from his perspective. So it's a little tricky. It would be a little challenging for someone to learn to move and control a player this way, but that's kind of the fun of it, I guess. So let's see, he rotates, and you'll notice I put a little jumping animation in there to make him kind of jump from tile to tile, which I think looks kind of fun. And if he falls off the edge of the world, he has problems and he dies, and I've got randomly generated messages that pop up, trying to be funny, different things it'll say to him if he falls off the edge of the world. Okay, those same two keep coming up over and over again. Again, it's all random. See, when things are random, sometimes random is, oh, there's a Seinfeld reference for you. So anyway, if he picks up the orange globe, then his score up here changes to 1, and we move to the next level. So this level, I wanted to show you what the water looks like. Here you see water tiles are in blue, and the tan and blue tiles I just call swamp. So if you walk into water, you're not that strong of a swimmer, so you die if you walk into the water. And just like falling off the edge of the world, you respawn in that same location. Now for the swamp, you can walk through it, but you fall down into your waist level. And I haven't added this feature yet, but I'm going to make it where you walk slower through the swamp than through land, so it slows you down. But anyway, so there's an example of water. And we go to the next level. I want to put hills in there. So here you see hills, the 1 unit higher than the ground is dark gray, then a lighter gray, and then even a lighter gray still as it gets higher and higher. And I've got it set up so you can only climb up 1 unit, or you can climb down 1 unit. If it's 2 units high, it's too high for you to jump up on it, so you're stuck and it becomes an obstacle at that point. Like a cliff face, you can't just climb up a cliff. You have to kind of find a way around. So let me get this I have each level is getting, the board's getting bigger too based on the level number. Okay, so when I first decided to make a terrain, I used just a kind of a random method where it would say, okay, each height of each tile is going to be plus or minus 2 units of the tiles that are surrounding it, at most. Sometimes it'll be level, sometimes it'll be 1 unit higher or 1 unit lower, at most 2 units higher or lower. But that's all it looks at, are the surrounding ones, and it gives that randomness to it. And it's like, as you can see, the example here, it looks way too random. If I press in, I can toggle through and have it regenerate the board for me, different random boards. You can see it's all too crazy there. So I decided this method's too good. It's not a realistic terrain at all, what you would see in nature. So I wanted to improve upon this. So I decided to switch from this kind of really very random approach to a more stochastic approach where it's still randomly generated, but instead of just being haphazard like this, what my new method does is it generates peaks. Like, you tell it how many hills do you want it to generate, and it randomly locates the position of the top of the hills. And also, how many ponds do you want, and it randomly locates where the depth of the pond is going to be. And then it runs through an algorithm as it's placing the tiles. For each tile, it says, okay, it calculates based on where all the other peak locations are in relation to that tile. What's the distance to it? And the closer that tile is to the peak of a hill, the more it's going to draw it up and make it a higher elevation. And the closer it is to a pond peak, the more it's going to drag it down and make it be water, or make it be swamp, or at least ground. So it's that was interesting doing all that business. I love them. You know me, you know me a little bit. I love all the math that was involved trying to figure that out. A lot of inverse distance squared kind of stuff, like from physics class. It's kind of what I was thinking. And I can change the power, actually, so it's not maybe distance squared. If it's distance cubed, then the landscape is even more smooth, say. Or if I do the distance to the power of 1.5, then it's a little more jagged. So I've got this kind of parameter controls in there, and played around with those a bunch. So anyway, obviously this is no good. So what I need to do is I can't go to the next level until I get a globe that's really close to where I am. There I am. So I'm going to grab that globe so I can go to my next level, so I can show you my better terrain. Alright, so there we see the more realistic terrain. For this one, let's see, I think I've set this one up to be 2 ponds, and I thought 3 hills, but if the hill peaks are close together, it might look more like just a group of hills, or a line. Maybe we might have a hill peak that's here, and maybe there's another hill peak over in this area, kind of making this area high, but it's not as high of a peak as this one. So that one is kind of making it, it's a plateau look out that way. And we can see our water there, and of course, if I fall in the water, of course I'll die again. But let me go ahead and get this globe so we move on to the next level, which is more of a realistic kind of level, where I've got more ponds, more hills. I threw in tree objects to be another barrier that you kind of have to work around. And for this level, this is more realistic of a level. You see we have to collect 20 globes. We've found 0 so far, so we're keeping score as we go through here. I've collected 1 globe, and now I've got more globes to collect. The tricky part of moving this character is, it's fine if you're looking straight ahead. You can think E and W move you right or left, and you can kind of have them walk side to side like that, which is kind of fun. But as soon as you rotate around, it becomes a little disorienting. What does E do? E moves you actually, from our perspective, to the left, not to the right. So I wanted to build in where you can change the view. So if you hit the V key, you'll change your view to a first-person look, and I can still do my same kind of motion, move around, pick up globes. Still using the same controls. So there we go. What I want to add is you notice as you rotate, it just jerks from to each 60-degree angle. So I'm going to add in a smoother turn to animate that. Haven't got to that yet. So I should point out, I've kind of approached this project kind of like almost like an agile approach would have been taken, where I just had these different ideas, features I want, each idea one at a time. That sort of focused my attention to learn that kind of element of Unity, what I needed to know. With each feature that I added, I always ensured that the thing was working. You know, it had to be shippable, right? And that kind of cool. It kept me on track. It kept me from getting in too much trouble with anything not working. When I'm in this view, if I arrow up and down, use the up and down arrows, I can actually zoom in and out. So I can zoom to a view like this, which I think is the easiest way to play the game. So I can kind of see more of my surroundings, but I'm also always in the orientation of being behind the player, so my E and W don't get confusing how to move it. So that was kind of, you can put a camera actually attached to the player to follow him around. That's how this is accomplished. So you can do some pretty slick stuff with Unity. I could put a camera, I could tell this thing this is a 2D game, and put the camera straight above the board, and I could get a very flat look, just an overhead view of this, and kind of turn it into a 2D game where it behaved the same way, but wouldn't look as cool that way. So I'm trying to think what else maybe I should say about this. Then it gives you an idea, though, of what I've got so far, and hope that's cool. I don't know if you guys do 3D games or not, but like I said, you can always turn this into a 2D game very easily in Unity. So hopefully that looks good to you, and hopefully I can be your Unity developer someday. I've got, alright, I'll just send you an email. I'm going to put this up on YouTube, I think, and send you a link to it by email. So I'll talk to you later. Well, I was thinking maybe I should say a little bit more, if you care to hear about it. Just to mention kind of some of the back-end stuff I did here, what I've been learning specifically to make this, to accomplish this. For one thing, I've done all my scripting in C#, and here's a list of my C# scripts. Each script actually acts as a class, and you can refer to variables and objects in one script from another script simply by using kind of the dot operator and class structures, that sort of thing. So let's see, what have I got here? Got kind of a hierarchical structure here. So when you hit play, it generates all these tiles. Well, I have it create a folder, an empty game object, to act as a folder, and then all the cylinders, those are the tiles, are actually just little skinny cylinders. I put those in there so they become children of the parent. The tile is the parent. And then it does the same thing for the globes. There's all my globes. In this case, there's only one globe. And then here's my player. And he's got a capsule, which is his body, a cube, which is his nose, and the following camera for when we go into first-person view, where we can zoom out using that follow camera. So let's see. The coding happens over here. This is the mono-develop tool they give you for doing the scripting. This GM is Game Manager, where we keep a lot of things. For instance, in the Game Manager is where we set up our levels to say what size we want our boards to be and how many ponds and hills do you want in each one. And I set it up so each subsequent level would remember the previous level settings. So really all you need to do for each level is kind of change the things you want to change. Random was the terrible board pattern where it was too random, too jagged, and then stochastic is what I call the board generation method, which is more smooth. So when it goes to create a new board, it looks to say, well, what board generation style should I use, random or this other method, stochastic method. Here I set some values I want to use for my animation. In this methods class I made, I realized I needed a bunch of little functions to call at different points in time. For instance, I created a little function called random integer, where I wanted to be able to feed in the minimum, maximum value for the integer, and also, but not only that, because that would give me just a uniform distribution, which is kind of what's built into Unity, but I wanted to have the ability to say, hey, I want the values in the middle to be more likely than the values at the extremes, for instance. In that case, my mean value would be my most likely value that I want to occur. And I can set alpha and beta parameters to kind of control the function curves that generate those values, to emphasize those. And let's see, I actually put those, here's a picture of it in Excel. I figured all the math out in Excel and graphed it and be sure it was all working properly. Then I put all the functionality into that function in Unity. Here we can see I set my min to -2, my max to 3. I want my mean to be 0. I want that to occur more often at a rate of alpha equals 8. So if my alpha is 0, you'll see I get a straight line distribution. This is a uniform distribution. And if I make, actually the beta needs to be 0 also, then you can see this is kind of the float value between 0 and 1, and then I extrapolate that to be integers. So here's our -2, -1 integers between -2 and 3. So this is the graph of the actual output of that integer function. If I change the alpha to a bigger number, like it was before 8, then see that's almost kind of curves back down, doesn't it? Maybe make it 7 or 6. The idea is that you want the graph to flatten out at the area that you want. So notice from our integers there, now you have a 0 is occurring much more frequently than the other values, but it's a little bit skewed to more to the left than to the right. So you can change the beta value, will actually skew that back a little bit. So that's all some of the details into just an example of one of the methods that I worked on. So I did that for random integers. I did the same thing for just if I needed a random float number, with the same idea of having this most likely value option in there. Let's see. I needed a little function to tell me, hey, I want to feed into this function the locations of 2 hexagons, and I want this function to spit out the distance between those two. And I was using that for my terrain generation to see how close they were to peaks and ponds, to help decide the height of each tile. Here's a little simple script I put to say, hey, here's some XY coordinates, is it on the board or not, based on the board dimensions. So that's what this little function does. So different things like that I found I needed to reuse over and over again, I'd throw it in there. That forced me to learn how to use classes and how to have these things talk to each other. And the map class that I have right here is actually the script that generates the map, does some initiation, and then right down here it creates the board. Here it creates the folders to put all the objects in. And one of the trickiest parts was the fact that it's hexagonal and not rectangular. Added a whole level of complexity to it because I wanted a simple X and Y coordinate system, but in that case everything's going to be kind of at a 120-degree angle instead of 90-degree angle on the axes. So I ended up generating these boards that were parallelograms instead of rectangles. So I had to chop off the ends of the parallelogram to make the things rectangular. So that was interesting to figure all that out. That's what this does. You tell it what you want your board width to be, but then it calculates the required width. It's got to be, so it makes it wider than the board width you want, so you can put the parallelogram then will be long enough to generate it. And then depending on the kind of generator I want, here's my peak terrain generator where it generates all my peaks. How many grounds and how many ponds, how many hills to put in. The mathematics behind that. Again, I use Excel, use a spreadsheet to figure out all the math, making that, being sure it works, and then I put it into the code. It's not the only reasonable way to do that. Here's creating the tiles, it's creating the trees, it's creating the globes in this section of the code. And there's another one called player, and this is the function actually looks for input from the user to see if you have the right key or the left arrow key or the E or the W, so you could actually move forward whichever direction you want to go. Here's the, this is when you've actually made a move. This is it moving, it animating it. And when it's done moving, then it checks to see if you got a globe or if you fell in the water or if you fell off the board. It generates the little message, respawns you back where you started if you died. So very educational process, learning to do all this stuff and kind of figuring out a little piece at a time. Gotta say kudos to Chris Parkinson. He helped me 2 or 3 or 4 times on some pretty major roadblocks I was stuck at, trying to understand how the game objects in Unity in the tool, the game objects that you make, in here, how do you connect those to the scripts? How do you have scripts talk to each other? Those sort of things were not really that clear in a lot of the documentation. And once he kind of showed me a couple of those things, it was like the clouds parted and the light shone in, and it kind of all made sense, and that kind of got me up and running. So really appreciate his help. So anyway, that's enough about that, I guess. Feel free to ask me any other questions about this stuff you'd like to know about, and I guess I'll talk to you later.